Hello, pre-calculus students. This is a lesson on converting rectangular equations into polar equations. So rectangular equations are those that have x and y in them, and polar equations are those that are written as r, the radius, and theta. So we have a function here or an equation here with x in it, and we want to convert it into something that only has r and theta. So let's just bear in mind the ways that we can convert between polar and rectangular. X is always r times cosine of theta. Y is r times sine of theta. And we can also say that x squared plus y squared is equal to r squared. Okay, and so these are the three ways that we have for converting between rectangular and polar equations. So in this first equation, I'm going to just convert the x into r cosine of theta equals 2. Then I'm going to divide both sides by cosine theta. So r equals 2 over cosine theta. And in fact, I can stop here as soon as I get r by itself. So r is written as a function of cosine of theta. I can also take this another step and say that it's 2 secant of theta. Okay, and both of these functions are perfectly fine. So let's move on to something a little bit more challenging. Here I have x and y. So I'm going to rewrite x as r cosine theta and y as r sine theta. And my goal is to get r by itself. Okay, so we want to, I'll make a note here, we want to write equation with r as a function of theta. Okay, so we want to write r as a function of theta. So we want to get r by itself. So that means I'm going to factor out r here. So factor r, I get 3 cosine theta plus 4 sine theta equals 2. And then I'm going to divide both sides by 3 cosine theta plus 4 sine theta. And that gives me 2 over 3 cosine theta plus 4 sine theta. And so if I graph this equation in polar mode, it's going to give me the same thing as if I graph this in rectangular mode. And another way I can write this is y equals negative 3x plus 2 over 4. Okay, so if I graph these two, they should give me the exact same graph. So let's just, as a proof of concept, do just that. So let me go into my mode here and go into function mode, clear everything out, and I'm going to graph negative 3x plus 2 all divided by 4. Hit graph. You can see I have a graph of a line with a negative slope, negative 3/4 in fact, and a y-intercept of 1/2. Okay. Let me change this into polar mode and graph 2 divided by 3 cosine theta plus 4 sine theta. And hit graph here. And it's going to take a little bit of time. It's going to draw the line there, and it's going to draw it in the other direction as well. Okay. And you can see that I have the exact same line here with a negative slope, and I can trace through towards the origin here, and as x gets closer to 0, y is going to get closer to 0.5. And so you might want to, you're probably thinking, you know, why would anybody bother to do this if we can already graph lines? Well, this is really just a proof of concept. It just tries to show us what we could do. And then this next example here, you'll see why, the real power of using polar functions. So this here, I know in this next function, this problem, I have x plus 3 squared plus y minus 2 squared, and I know that this is a circle with a center at -3, +2, and a radius of square root of 13. Okay. But the problem is I can't graph this in function mode. But I would be able to graph it if I moved it into polar mode. Okay, so what I'm going to do first here is just FOIL the entire expression. So I get x squared plus 6x plus 9 plus y squared minus 4y plus 4, all that's equal to 13. And I'm going to put all my x's, at least my x squared and my y squared together. So x squared plus y squared plus 6x minus 4y plus 9 and 4 is going to give me 13. Okay. So you can see if I subtract 13 from both sides, I get x squared plus y squared plus 6x minus 4y equals 0. And now I have it in terms of x squared, y squared, x and y. I can use these conversions, and this will give me r squared. 6x is going to give me 6r cosine theta minus 4r sine theta equals 0. I'm going to continue the problem over here. I'm going to factor out r, and that gives me 6 cosine theta, or sorry, I should include that first r there. So if I factor out r, I will get r plus 6 cosine theta minus 4 sine theta equals 0. Using the zero product property, this will allow me to get two different equations, r equals 0, which is basically just a dot at the origin, and r plus 6 cosine theta minus 4 sine theta equals 0. And then move everything to the other side in order to get r by itself. So r equals -6 cosine theta plus 4 sine theta. And once you get r as a function of theta, you know that you're done with this equation. And so now I can graph using my calculator here, and just to see that it is in fact going to be a circle. So -6 cosine theta plus 4 sine theta. Graph. You can see there it's going to be a circle. The radius is going to be -3 and 2, and sorry, the center is -3, 2, and the radius would be the square root of 13. Okay. And so there you have it. 3 examples on how to convert rectangular equations into polar equation, and keeping in mind that the reason that we do this is so that we get a function that we can actually graph when we might not be able to graph it in rectangular mode.